So this morning, I'm going to do my best to go over the homework assignment that you had, um, which was number 3 on the electron configuration sheet. And here we're working with an orbital diagram, and specifically the orbital diagram for phosphorus. So how would we go about working on this orbital diagram? If we go to our reference materials, first of all, we need to find out what is the atomic number for phosphorus. So if we look at phosphorus right here, we see that it's atomic number 15, which means that we need 15 electrons in our orbital diagram. So 15 electrons, and we're going to start off going back to now our yellow electron configurations folder, and we have notes. And in these notes that we went over one of our previous classes, our electrons are represented as arrows, the subshells are represented with boxes, and we can have a maximum of 2 arrows or electrons in each subshell or orbital. Now, there were 3 principles we had to work with. The Aufbau principle was the first one. Aufbau means we start in the lowest energy level. That means that our first electron is going to go in the 1s. So we're not going to put it in the 2s. We're going to put it in the 1s. Let me go ahead and save this. But it doesn't get deleted. Now, the next principle that we were working with, we go back to our notes, was the Pauli exclusion principle. Pauli exclusion principle teaches us that in each box of our orbital diagram, the arrows have to go in opposite directions. So we start with the up arrow, then we have a down arrow. And this is representing the different spins in a given subshell or orbital for the electrons in that orbital, because in the electrons have the same charge, so they have to be spinning in opposite directions in order to occupy the same region in space. So here we go, and we're going to put in our second electron. Now we know that we need 15 of these. So the second, the 2s subshell, is also going to need 2. Oops, put my pen back. The last rule that we learned about was Hund's rule. And the idea of Hund's rule is that because the electrons like to have this, well, the electrons have the same charge, they have to spread out. If you have multiple orbitals, each one of these boxes, this is the 1s subshell, the 2s subshell, this is the 2p subshell, but notice that the 2p subshell has 3 different regions. These are 3 different orbitals. And in the homework that you did when I was absent, each one of these orbitals occupies a dimension in space. So this is 2px, 2py, 2pz. So the electrons, because they have the same charge, they like to spread out in space. The idea is, it's also called the empty bus seat rule, because the idea is that if you're on a bus, you generally want to spread out. Let's say it's really hot outside and people are all sweaty and dirty. So the electrons are like sweaty, dirty people who want to separate from each other on the bus. Um, and that's why we're going to fill out this 2p in this way. The 2px, 2py, 2pz. So there'll be a separation when you fill out your orbital diagram. Now, we still have, let's see, how many electrons do we have? 1, 2, 3, 4, 5, 6, 7. We still need 8 more electrons. So we will fill up all of the seats on this 2p subshell bus. We still will fill up all of the orbitals, the 2px, the 2py, the 2pz. However, we represent that filling with down arrows, and the filling is done after all of the up arrows are in place. So at this point, you have 2, 4, 6, 8, 10. We need 5 more to make the 15 electrons for phosphorus. So now, to make the 15 for phosphorus, we're going to add in another 2 here in our 3s. So again, following Pauli exclusion, it's up and down, opposite spins. And now we need 3 more. So this is the 3p. So the first thing we have to do, we have to follow our empty bus seat rule. So we're going to go 1 up, 2, and 3. So just like this one. And that actually gives us 15. So in this one, there are no down arrows. And that is how you would complete number 3, which was the homework.